Welcome to the Nanovax Podcast, a Nanovaccine Institute curated podcast sharing the latest research and advancements in nanovaccines and nanotherapeutics for human and animal health. The Nanovaccine Institute is a consortium of researchers, institutes, national laboratories, and companies founded and coordinated by Iowa State University.
We are developing nanovaccines and nanotherapeutics for respiratory infections, neural disorders, antimicrobial resistance, cancer, aging, and animal health.
Our vision is that nanovaccines and nanotherapeutics will revolutionize how we prevent and treat disease.
Hello, I'm Kathleen Ross.
I am Balaji Narasimhan.
I'm Mike Roof. This season, you will hear from experts across a range of disciplines who study respiratory diseases and antimicrobial resistance.
The first half of the season will focus on respiratory disease and antimicrobial research within the Nanovaccine Institute. The Nanovaccine Institute is pioneering the development of novel, nano-based countermeasures, such as in a universal influenza vaccine. We will also talk about other emergent and impactful diseases that have radically changed how we consider and develop policy around global public health.
The second half will focus on the challenges and countermeasures to antimicrobial resistance. Nanovaccine Institute researchers have developed novel nanomedicine therapies to treat chronic disease caused by bacterial pathogens that have developed antimicrobial resistance.
Episodes will explore the different corners of these research topics through presentations on the latest findings as well as conversations among the experts.
So the podcast is, at least I think of it as a way for us to expand how we communicate about the advances that we're all working on to a wide range of constituents. These could include students, these could include the general public, people who are interested in knowing what's happening, but also professionals in the field, industry professionals, hospitals, medical doctors, policymakers. So the intent is to really communicate in a very simple but effective way what we're doing, what are the benefits of what we're doing, what the limitations are of what we're doing, and where this is going, and talk to experts who can talk about topics that are timely and communicate to all of these constituents accurately the science and the impact of what we're doing.
Yeah, I think in some cases, especially since we've gone through a pandemic recently, there were a lot of fears that came out of that. And so I think for us to be able to kind of break down the science and explain it in ways that people can understand really can help, kind of ease people's concerns for new treatments that come out, as well as just understanding the basics of why some of these policies are set in place.
Yeah, as Balaji said, I think the primary value for me for this podcast is to connect the non-experts with the technology, see how it might apply to their daily lives, and get them integrated into what the opportunities are for the nanoparticles and the nanovaccine technology.
So the Nanovaccine Institute has experts from a lot of different fields, all the way from very basic science through to what I call formulation science and engineering, and then moving towards expertise with animal models, which is something that Iowa State is very, very well known for. And then, the further downstream aspects of testing these in relevant animal models preclinically and then onto the clinic, wherein we have expertise from individuals that have performed clinical trials or from experts from industry who regularly do this.
Yeah, I appreciate the Institute in its attendance because I'm a biologist, but the Institute itself has engineers, biochemists, other biologists, and it's one of the few places where all of those interdisciplines come together and work on common efforts. And so to me, that's how I enjoy and value the makeup.
Yeah.
And I think the other addition beyond sort of the technical expertise is policy expertise and socioeconomic effects of these nanovaccines or next generation vaccines that I think is something that often people who work in the sciences don't consider at the earlier stages. So it's nice to see that aspect come out. So to both of you, what do you think is the purpose of the Institute?
I mean, I think Mike kind of was hinting at it there that, we have collaborations of engineers, biologists, virologists, and, today's public health challenges really aren't, things that can be tackled by a single field. So having a place where these different fields and people can come and work together can really help us overcome some of those challenges.
Yeah, similar to that, I think the technology around nanoparticles has been well characterized and described by a variety of institutes and principal investigators. And I think what the Nanovaccine Institute does is helps us begin to take that out of the academic center into the commercial space or being practically applied. And so to me, that's the value of taking proven technology and making it valuable and used in the industry.
And the problems we are trying to solve are very complex and very global, as we saw during the pandemic that we all just went through. And so solutions need to come from everywhere for these types of problems. And so the Nanovaccine Institute is a possible home for everybody who's thinking about different aspects and maybe who are at different stages of the pipeline in terms of the solutions, and then bring them together to see if we can solve or at least come up with some solutions for these global problems.
So since the Institute is based here at Iowa State University, what do you guys think the benefit is of having it here in Iowa versus other institutes across the United States?
So I think there are multiple advantages that Iowa State University and honestly the location in Ames here brings to the Institute. We are uniquely positioned with respect to having expertise both on the academic side, but also on the industry side and on the regulatory side with respect to vaccines here in Ames, Iowa, with the confluence of vaccine-related industry here. Boehringer Ingelheim, Merck come to mind as two examples. The National Animal Disease Center, which is a USDA national lab, as well as the Center for Veterinary Biologics are both in Ames, and then the expertise at Iowa State in animal health, as well as in new technologies, engineering-wise, really make Iowa State sort of a place with triangulated expertise, in my view. The other benefit I see of this kind of research and the presence of such an institute here is Iowa State University is a place where there are very low barriers to collaborate. This institute is all about collaboration. People from different fields have to learn each other's language, work with each other, and make advances that would not be possible if the environment was not supportive of collaboration. So that's another benefit I see.
Yeah, similar. I work with the bioscience platforms through the state of Iowa, and so there are a variety of institutions as well as companies that value this technology, ranging from the University of Iowa, where a lot of the human medical applications are. Balaji already highlighted the intense animal health opportunities here. But, from a state perspective and our commitment to agriculture, it can be plants, it can be agriculture. There's even applications in digital health. Some of these nanoparticles form things that are sensory in nature. And so Iowa makes a perfect place to not only test this, but develop and expand its use.
Some of the emerging issues that I think will be discussed in the season, especially applying to respiratory disease. Things like transmission, I think, are things that will be really important for us. As we talk about the pandemic or avian flu, the one thing we're really worried about is transmission from person to person. As these viruses evolve, we're always hoping that our vaccine will cover the new strain of the virus. But those are definitely challenges that we're working on here at the Nanovaccine Institute.
And I think making the vaccine accessible to users, whether it's humans or animals. So, for example, how do you deploy a vaccine in a barn that is full of animals? How do you effectively deploy this vaccine in a part of the world where transportation is not very accessible? These are important questions that are limitations that we learned about, during the pandemic and during other outbreaks of animal disease. So So managing respiratory disease also, I think, involves accessing the vaccine and providing easy access of the vaccine to the users.
Yeah, one additional thing that's sort of timely on the emergent issues are we all went through COVID, and we know what that is, but as a recent example, Iowa State has identified that influenza can now affect cattle, which is the first time this has been discovered. And so having technologies and solutions that can be rapidly deployed in the face of new and emerging diseases becomes incredibly important. And nano vaccines and nanoparticles as a platform could play a very important role in that, especially given the vast amounts of data we have with influenza in nanoparticle-based vaccines.
Yeah, so that's a nice segue into sort of what the nanoparticles offer with respect to disease management. So I can think of, nanoparticles, they can be administered needle-free, which is, I think quite a big deal. We don't have to worry about infections through needles or disposing of needles or the need for professionals to administer needle-based shots as one advantage. I think a lot of our preclinical data is showing that these nanoparticles or nanoparticle-based vaccines induce long-lived immunity. So, instead of constantly going back and getting booster shots, can we lower the frequency of those booster shots and get long-lived immunity in a single dose? The nanoparticle-based vaccines have the potential to do that. And to me, another game changer is the fact that these nanoparticles can be stored at room temperature for long periods of time. So all the vaccines so far that have been approved for human use need to be stored cold. And so by removing the cold chain from the equation, we would dramatically simplify the logistics and transportation and shelf life of these nanovaccines.
Yeah, I think, when you talk about accessibility, removing that cold chain, not only provides, people in other parts of the world to be able to receive these types of vaccines, but also substantially reduces the cost of these vaccines. So, we're kind of lucky in our situations in life here in the United States to have ready access to good health care, but there are definitely those in the world that don't have that type of accessibility, and hopefully by using kind of dry powder-based vaccines, we can eliminate some of those challenges.
Yeah, I think COVID sort of exposed our system a little bit. We do have the best healthcare in the world, and yet when a deep frozen product was required, it was certainly a challenge. And if a nanoparticle stable vaccine would have been available, it would have been a game changer.
I hope somebody does that analysis someday. Perhaps we should about what if we had this versus what compare it to what we had and see what the difference is.
Yeah. We've talked a lot about respiratory disease, kind of talking about the antimicrobial resistance. What kind of challenges do you see with bacterial pathogens?
Well, bacteria are a big challenge because there's so much pressure to get rid of antibiotics. And so two things, get rid of antibiotics, and we do have a bit of a culture right now where people are declining vaccination. And so there are diseases that in the past have been either limited or almost eradicated that are now coming back. And so there's a second wave and an increased level of interest in doing bacterial vaccine research because these diseases are becoming more and more important because the tools we use to control them are either being limited or removed from the market. And so all the major companies and a lot of the federal granting opportunities are now focusing more on the bacterial diseases, which is a bit of a change from the past maybe decade or so.
I also think secondary infections due to bacteria are very common when people, especially maybe the very young or the very old, get hospitalized with viral infections. And oftentimes that secondary infection is what gets you in the hospital. So I think bacterial pathogens and countermeasures against are very, very important, even in the context of viral infections. And there's always the threat of superbugs that's out there that people talk about that I don't think we're prepared for at this point. But hopefully some of the research that the Nanovaccine Institute and other similar consortia are performing is going to give us some clues as to how we go about coming up with countermeasures. So, as we wrap this up, so what are we optimistic about with respect to the future of the kinds of things that we're all working on?
Yeah, I think one of the most exciting things I've observed is that technology has advanced to the point where it is now regulatory acceptable and approvable to license and use platform technology. And that platform technology allows us to respond quicker to new and emerging diseases. It allows us to provide safer vaccines and hopefully in the near future better and more efficacious products. And so examples are, CVB has instituted new policy on what they call platform or prescription vaccines. And so they now allow, I'll use an example, baculovirus or alphavirus as vector platforms. Certainly RNA vaccines would be in that. And as we've seen from COVID, which the vaccine response there in a lot of ways was a platform-based extension from SARS. And so I think these platform technologies and the government's policy to allow their use in an accelerated way, to me, is really exciting. And it's exciting to animal health, it's exciting to human health, and I think we'll see more and more of that in the near future.
Yeah, I think, speaking about the last pandemic, the speed at which we were able to have a vaccine roll out to the public was just a tremendous effort, and amazingly done, as quickly as it was. And we hear lots of times now about having a 100-day challenge, when we identify a new disease within 100 days, can we have something ready to help people? And that used to kind of make me raise my eyebrows a little bit, but now with some of the research we're working on, I say, yeah, we can do it. So I'm pretty optimistic about, being able to have that turnaround and accessibility and really helping people in some of these tough public health situations.
Yeah, I couldn't agree more. And the only thing I'll add to what both of you said is I'm also excited about the opportunity to design vaccines and therapies for what I would call underserved populations. I think people on both ends of the age spectrum, the very young and the aged, as well as individuals who are immunocompromised, individuals who are pregnant. Vaccines and therapeutics are generally not designed keeping these individuals in mind. But I think the advances in AI-based work, in platform technologies, as Mike was pointing out, and hopefully room temperature stable vaccines, with safety being a huge part of this, we can maybe make vaccines for all. And that's, I think, a very exciting and very well worth pursuing goal that brings us all back to work every morning.
Yeah, well, thanks for the conversation, guys, and hope our listeners subscribe and tune in to the rest of the podcast series.
Look forward to it.
Likewise.
Nanovax is a research-based education program hosted by the Nanovaccine Institute. Connect with us on LinkedIn. This program is brought to you by the Nanovaccine Institute at Iowa State University. Iowa State University is an equal opportunity provider. For the full non-discrimination statement, please visit the link in the show notes.